Assalamualaikum. 大家好，我叫Ainan Nadira from 4 Science Streams. So today I'm gonna teach you about basic concept. What is the meaning of matter? Matter is something that has mass and occupies space. Matter consists of particles that are tiny and discrete. Matter can exist in three states, which is gas, liquid, and solid. These are some examples of gas, liquid, and solid. That's all for today. Thank you for watching.
Assalamualaikum teachers and friends. I will explain about the changes in state of matter. First, I will explain about solid. The particle in solid are closely packed in an orderly manner, and kinetic energy of particle is low. The attraction force between particle is strong because it is closely arranged. Next, I will explain the characteristic of liquid. Particles in liquid are closely packed but not in an orderly manner, and kinetic energy of particle is higher than solid state. The attraction force between particles is strong but less than solid. Next, I will explain about gas. Particles are far apart. The kinetic energy of particle is very high. The attraction force between particles is weight. Now, I will explain about the process that involves in change state of matter. First one is melting process, where heat energy absorbed and the energy will increase. So, the solid will change to liquid through melting process. The evaporation of boiling process, where the liquid will change to gas. During this process, heat energy absorbed and energy increase. Next is condensation process, where gas change to liquid. During this process, heat energy was released and energy will decrease. Next is freezing, where liquid will change to solid. During this process, heat energy was released and energy are decreased. So that are four processes that involves in the change in state of matter. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Saibay Haki and I'm gonna present to you the heating curve of naphthalene. This is a graph show that the heating curve of naphthalene. It has four sections. There is A, B, C, and D. Alright, from A to B, the temperature increase and the naphthalene, the particles, exist in solid state. You can feel the shape, you can see the shape of the naphthalene. And when heated, the particles absorb heat energy and vibrate faster because kinetic energy increase. So, from B to C, this section is the melting point for the naphthalene. So, B to C melting occurs. No increase in temperature because heat energy absorbed by the particles is used to overcome the attraction force between the particles until solid changes to liquid. So, there's no increase in temperature here because the melting occurs. Alright, and lastly, from C to D, the temperature increase once again and exists in liquid state. Because it has melt, so it exists in the solid in liquid state. So, when heated, the particles absorb heat energy and move faster than before. Move faster from A to B and faster than B to C. So I think that's all for the heating curve of naphthalene. I'll show it again to you. This is the heating curve of naphthalene, the graph. Alright, that's all for today. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. I'm going to present about the cooling curve of the naphthalene. From A to B, the temperature decrease and the naphthalene exists in a liquid state. When the naphthalene is cool, the particle release heat and move slower due to the loss of kinetic energy. From B to C, this is when the freezing occurs. There is no decrease in temperature from B to C because heat energy that is lost to the surrounding is balanced by the heat energy released when the particles attract each other to form solid. And finally, from C to D, the temperature decrease and naphthalene exits in a solid state. When the naphthalene is cool, the particle release heat and vibrate slower. That's all from me. Thank you.
Assalamualaikum. Today I want to talk about proton number and nucleon number.
This is some note that I made. Very simple. Okay. The number of protons in the nucleus of an atom is known as the proton number. So proton is located in the nucleus. We can look at page 29. This is proton is located in the nucleus. The total number of protons and the neutrons in the nucleus of an atom is known as the nucleon number. So for nucleon number, we just need to remember this formula, the green one, which is nucleon number equal to number of protons plus number of neutron, or proton number plus number of neutron. So for example, oxygen has 8 number of proton and 8 number of neutron. So 8 plus 8, we get 16. So the nucleon number of oxygen is 16. The nucleon number is 16. For another example, atom sodium has 11 number of proton and 12 number of neutron. So 11 plus 12, we get 23. So the nucleon number of atom sodium is 23.
Morning to my teacher, Puan Musfira. Today I want to present about standard representation. This is standard representation of an atom. A is the symbol of element. A is the nucleon number or atomic number, mass of atom or relative atomic mass. Z is the proton number. For example, sodium atom. Sodium contains 12 neutrons and 11 protons in nucleon. This is standard representation for sodium. Na is the element of sodium, 23 nucleon number, 11 proton number. Another example, carbon atom. Carbon contains 6 neutrons and 6 protons in nucleon. This is standard representation for carbon. C is the element of carbon. 12 is the nucleon number. C is the proton number. Thank you.
Hi, Assalamualaikum. My name is Nurbalkis Atira. I would like to share with you about meaning of isotope. Isotope is an atom of element. They have same proton number but different nucleon number. For example, hydrogen, silicon, and magnesium. Next, relative atomic mass of isotope. First, it's as a mixture of two or more, so an atom can have a mixture more than two. Second, it's depend to the natural abundance of isotope in a sample. Natural abundance is depend how percent of isotope in natural sample of an element. This formula can help us to find the relative atomic mass of isotope. Thank you. Assalamualaikum.
Morning, I'm Nurin Imani from 4ST. Today I'm going to talk about use of isotope. Right? So, radioactive isotope has many useful applications. For example, cobalt-60 is extensively employed as a radioactive source to arrest the development of cancer. Isotope is also useful for our daily life, such as in medicine, in agriculture, in food preservation, and generation of electricity.